All right, class, we're on chapter 8 now. We're going to wrap it up pretty quickly, talking about fractions. All right, we're going to talk about geometric fractions first, and this is when we're talking about area of a shape or area of a backyard or anything. So when you have spatial area and you divide it into equal parts, we're doing this. Okay, one of the most important things to remember from this lesson is the definitions of our fractional digits. When you have a fraction bar, you have two numbers that typically you will see, a numerator and a denominator. Numerator is the top number, and the denominator is the bottom number. 2 over 3 would be read as 2/3. You would see this as two parts of a whole that contains three parts. Usually we see them shaded in, but really it's anything that we're talking about, focusing on, or discussing in context. For instance, if we had this pie and we knew that somebody ate 2/3 of it, we'd be able to figure out what's left. So it's not necessarily about the shading, but what we're representing. So 2 of the 3 of these parts would be represented in these areas here, or any of the 2 areas in that pie or pizza. 2/3 represented like this. It can be shown in any shape as long as the parts are equal. Okay, our next lesson was about fractions of linear measure. Linear, of course, you can see in the word structure, refers to line. So rulers and meter sticks and the like all measure in linear measure straight line segments. So if we know a measurement, we would apply the same thinking to fractional measurements as we did with area. So it would just be as long as each section of measurement is the same as the rest, then the fraction is just the same as the numerator and the denominator. Okay, in this example, we have a 5-inch ruler. Even though the numbers are extremely small on this, I want you children to practice this with measurements that are longer. Because in this case, I can only go with the numerator no greater than 5, and the same for the denominator. We see that this ruler is divided into 5 equal inch sections. And if you just visualize this as a rectangle, you see fifths. So measurement is no different, except that it's just a flat line. We're talking about the fractional part of this right here. And as you see, it gets divided the same way a rectangle would be divided into fifths. So pardon these sloppy lines, but there you go. You see 1, 2, 3, 4, 5 sections. Or 1, 2, 3, 4, 5 parts of the line. Is this making sense, class?
Yeah!
Good. So, if I ask what was 2/5 of 5 inches, or 2/5 of this ruler, that would be very easy to see. That would be written as such. And now, since this ruler is way too easy for us, let me ask a question that the class can hopefully do orally. If this ruler was 20 inches long, what would 1/5 of it be? If this was 20 inches long, what would what would 1/5 be worth? So pretty, you're gonna have to yell it. Let's see. Count with me, children. 4,
8, 12, 16, 20.
Do it again, so I can actually make marks on the board. Thank you, that was perfect.
4, 8, 12, 16, 20.
So each of these sections is worth 4. Good job, Capri. 1/5 of this ruler here would equal 4. Or 4 inches, okay? So what if I asked you for 3/5 of this ruler? 3/5 of this 20-inch ruler. I don't know, maybe some crazy company made a 20-inch ruler. You still need to know what a fractional piece of that would be. 3/5 of 20 inches. Amira.
12.
12. Nice voice, Amira. Good job. Because as we know, we're going to have to be doing fractions of sets pretty soon. And this is just a set of inches. If I had 20 M&Ms and I wanted 3/5 of them, I would first divide them into 5 equal groups and then multiply it by the numerator, because that's how many groups I want. 3/5. So if each fifth is worth 4, then you're multiplying 4 times 3 because you have 3 groups of 4. I hope you followed all that, but we'll come back to that soon enough. Okay, moving on to fractions of sets. Here we're going to look at something very similar to what we just saw in linear measure. A set can be anything. It can be a set means a group. I remember talking about that in class. So if you have a group of anything, you can look at it as a fractional, that it can have fractional parts. Here we have a big group of stars. This is a set of stars. And we're going to figure out some fractions, but first we need to know the denominator, how many we have. So everybody quickly just count with me. I want to double check and make sure we know. 1,
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24.
There was 24 if you were paying attention. That's where I stopped, and that's why I stopped at 24. So we have 24. Right now, if I were to circle this, we could say what about that? Jasmine.
There are 4 24ths circled.
That's true. We could say that. Now, because just like any other fraction, there are 4 that we're talking about, highlighting, eating, shading, whatever. These are the ones that we're focusing on out of the total set. So this fraction is 4 24ths. But we see probably that this is not the simplest form of this fraction, because if I keep looking for groups of 4, I can see how many 4s are actually in this group. So I see another 4 here. I see another 4 here. Another 4 here. Another 4 here. Because yes, I do hope that you realize that there's a relationship between these two. Anybody who knows their math facts sees a relationship between these two numbers. And it's going to be confirmed in a minute. So we see that 24, when you're dividing it by groups of 4, you get 6 groups.
Yes.
So, if I said, what is 1/6 of 24? What is the answer? 1/6 of 24. Kevin?
4.
4. Correct. If we see this mess of a set is divided into 6, it doesn't look anything like our nice neat pie up here. It's not nice and neat anymore. It's all over the place, but the concept remains that there are 24. If I say 1/6, I'm looking for 6 equal parts. Here I have 6 equal parts. One of those sets is worth 6. Excuse me, is worth 4. 1/6. So 1/6 of 24 equals 4. Now that's the basic concept. What if we had a question like 4/6? What would 4/6 of 24 equal? Abia?
16.
16. Let's see if that's right. Here's one set, 4. Another set,
8.
another set,
12.
another set.
16.
Good job. 4/6 of 24 equals 16. And there you go. That's what you're doing. And some people, I'm going to just speak this out, some people know the algorithm here is that when you see anything out of your set and you want to find out the fraction of that set, you just divide by your denominator and multiply by your numerator. Hopefully you know that if your numerator is 1, you don't have to really multiply it because it's not going to change the number at all. So this one could have been solved without any picture right here, because you could have known that 24 divided by 6 groups, like we saw, Lewis, was going to come out to 4 in each group anyway. I was doing it in reverse, but either way. So times 1, you have 4.